Hello and welcome to this Micrographics webinar. Thank you for joining us. We're just going to give everyone a few more minutes to join the webinar, and then we will begin shortly. Okay, everyone here, now we can begin. Welcome to this Micrographics webinar. Today's topic is Autodesk Fusion 360, make use of surface modeling. My name is Irshad Hanif, and I'm an application engineer with Micrographics. Our agenda for today, we're going to be just discussing a little bit about me, just to tell you who I am, what I do, who Micrographics is and what we do. Then we're going to go into discussing the purpose of this webinar, and then we're going to jump right into the topics. We can talk about the design workspace, do a little explanation of surfaces, take a look at surfaces versus solid versus form. Then we're going to look at or take a closer look at surface tools. From there, we're going to look at creating solids from surfaces. And lastly, we'll look at the benefits of using surface modeling in your workflow. Once all the theory is out of the way, we will jump directly to a live demonstration where we'll open Fusion 360 and draw some very simple shapes and parts and show you how surface modeling can be leveraged as a design workspace. So without further ado, firstly about me, my name, like I said, is Irshad Hanif. I'm an application engineer with Micrographics. I've had approximately 8 years of experience in the mechanical engineering field. And my primary areas of expertise would be AutoCAD, Inventor, and Fusion 360. I also dabble in CAM, FEA, design and modeling, as well as product data management. So software like Autodesk Vault, if you guys are familiar with it, is also what I do. And I'm also a certified Inventor Professional or a certified Autodesk Professional, which means I've taken my exams and am now certified as an Autodesk Professional. All right, so the purpose of this webinar, we wanted to explore the Surface tab in Fusion 360's design workspace. And 4 key areas that I want to touch on is how to create surfaces, how to modify surfaces, how to create complete designs, and the benefits of using surfaces versus solids. So hopefully during the course of this webinar, we can take a look at those 4 ideas. So when you look at your Fusion 360 workspace, you know that all the different tool sets are separated by workspaces in Fusion. So in your design workspace, you will find multiple tabs at the top. Most people will primarily work in the solid modeling tab or sheet metal tab if they have a specific need for sheet metal. But one lesser used tab is the surface modeling tab, and that is directly next to the solid. So we can see that it sits in the design workspace. In the surface modeling tab, you'll find 2 main panels. One is create and the other is modify. So create is for making new surfaces from scratch. So if you don't have any surfaces, you can create something using very similar tools that you would find in Solid, such as extrude, revolve, sweep, or loft. The other panel is modify, and that will allow you to make changes to any existing surface bodies that you may have created. Okay, so you can think of surfaces as extrusions of thin walls that have 0 thicknesses. So they're very much the same way, although it's not a very accurate analogy, because you can have ruled surfaces, which we will discuss later on. But it's just nice to get an idea to understand it very simply, like an extrusion that has 0 thickness. A nice thing about surfaces is that they do not require closed loops like solid bodies. Often we will find that we don't know how the material inside looks, and hence we don't have perhaps a line to close up our shape. And sometimes we just guess, or we guesstimate. But if you use surface modeling, you can avoid that altogether. And like I said earlier on, most of the same tools from the Solid tab exist in surface modeling. So your extrudes, your revolves, your sweeps, etc. So let's take a look at that create panel. We'll have extrude, revolve, loft, sweep, right? I've highlighted the first 4, and those create thin wall surface extrusion, and I put in brackets there in the perpendicular direction, meaning it pulls out in a third dimension that's perpendicular to the plane that you have sketched on. So keep that in mind, as when we come to ruled surfaces, you'll see that's slightly different. Patch creates a wall surface joining a closed loop, and you can use guide rails to define exactly how that closed loop interacts with the third dimension. So instead of just making a circle and having that flat piece of circle be a thin wall, you can guide the third dimension to maybe make perhaps an oval or a curve shape of that circle in the third dimension. Okay. Rule surfaces. Okay, that feature basically creates a thin wall surface along a reference direction of your choice. So you know how I said that the first 4 will create an extrusion in a perpendicular direction, while a ruled surface can go in the same direction in which you draw your sketch on. For example, if you draw your sketch on the XY plane, normally an extrusion will be perpendicular to that, meaning it will extrude in the Z direction. So XY is where your sketch is, and you'll pull out in the third direction. But with surface modeling, you can just have a line on your XY direction, and you can pull out a thin wall surface of 0 thickness in the X or the Y direction, even though you've drawn your sketch on those 2 axes on the XY plane. So it's not pulling out a third dimension. You can just do it along a reference direction of your choice. And last one is offset. So offset creates a copy, in inverted commas, of a face offset at a certain distance. So for example, you can think of a solid where you have a face on it, and you can select that face, and it would create a sort of like a construction plane. In fact, it looks very similar, except construction planes have to be flat. So this can do any curved or organically shaped curved surface and raise that surface up or into the part at a certain offset. Now let's take a look at the Modifier tab. And the modifier will have 4 main tools. There are others, but I've just left the 4 main ones. And those are trim, stitch, extend, and reverse normal. Trim trims away surfaces beyond a reference sketch. So what that means is you can have a surface and draw a sketch that intersects with that, and it will draw a sort of guide surface telling you what will be removed, and that will usually be a sort of a blue window that you will see, or a blue surface that you will see. And anything outside that blue surface, you can click on those surfaces and simply delete it. We will see how that looks once we get to the live demo. Stitch. Stitch joins two surface bodies into one. So remember, when you create surface bodies, they operate very similar to how solid bodies interact. What that means is that when you create a surface, in your bodies folder, you will see a body appear, but it will have a different icon. It will have sort of an orange paper or cone looking icon. This is to indicate that it is a surface body. So when you have multiple of those bodies in your body folder from your model tree on the left, you will see that you are able to join these two surfaces together and make them one. So it's very similar to the combine feature in solid modeling, where you would combine two separate bodies into one. The next one is extend. Extend extends an edge of the surface to make it longer, which is fairly straightforward. You have created a surface and you would like to use one of the edges to elongate it. You simply click on that edge and extend it. And the last one is reverse normal. That simply flips the top or bottom surface to the other side. So you'll see when you create surfaces, you have normally one is the top side and one is the bottom side of that surface. So perhaps you have two surfaces and you want the tops to match. You can click reverse normal to flip one around and make them match at the same side. So what are the benefits of surface modeling? Well, this allows complex shapes to be made without needing a solid block to start with. If you take a look at the picture embedded in the background here, you'll find that that has a very organic shape. But it would be very difficult to start making the shape just from a solid block. Think about all the curves and lines that you would have to cut out just to get this simple shape. Therefore, surface modeling can help you mold and cut out these things using extrusions, loops, and sweeps. Another thing is it does not require closed loops. So we said that earlier, that surface modeling does not require closed loops. So again, if you look at the picture here, the end is open and free to do what you need with it. So if you want to tweak this or maybe modify certain points, or maybe add in a solid piece that you've already made, you don't need to close it or force any unwanted geometry in there. The next one is another benefit, basically, is it becomes useful when tracing organic shapes where not all the measurements or data is known. So if you think about certain arbitrary shapes, you don't always have a point-to-point measurement to give in data as you would in solid modeling, where you can just say, I'm going to draw the shape and I know X is going to be 50 mils and Y is going to be 25 mils. If you look at a more complex shape, you don't always have that at every single point. And you're not going to have that until you put in all the data you do have. Okay. We must also remember that surface modeling can be used in conjunction with solid and form modeling. So just because you've made a surface body doesn't mean that it has to be only within that surface tab. You can go back to the solid tab, create cuts, create solids, create joins, and merge the two and get the exact shape that you're looking for. And the last benefit is, of course, a greater control using skeletal sketch elements. So if you have a very cleverly made sketches on your surfaces, you'll find that you are able to grab your sketch points and drastically change the shape without having to go and make multiple cuts like you would in solid modeling. Okay, with that being said, let's go to a live demonstration of the surface modeling tools in Fusion. So here's our design workspace in Fusion 360. You can see that I'm in the design. I'm going to hop over to the Surface tab and jump straight into it. Notice I don't have any parts drawn yet, and I'm going to start from scratch. So first things first, let's take a look at a very basic shape. Something as simple as a square. So if I look at this and I can say now, to illustrate the point about not needing closed loops, I'm going to make one of these sides a construction line. And I'm going to say save. I'm going to go to my create panel and simply use an extrude along that open-ended loop. You'll see that it gives me the same option as if I were extruding in a third dimension, except I don't have a thickness and I'm not filling the material in here. I'm going to say, for example, 100, and I'm going to say OK. So I've just created a extrusion using surface with an open loop. I'm going to reactivate my sketch and try and do another one just to show, or perhaps maybe I'll draw a new sketch just to make it simpler. Now what I want to do is I want to draw a certain type of line. So let's take a look here. Perhaps I'll project those two. Second snap on. And maybe I'd want to have an arc at the front. So I'm going to make it 250. And I'm going to trim that and trim that. I'm going to say OK. I'm going to do another extrude, also at 100. And notice how I have one surface body here, and this is the icon I was talking about. So that surface icon, it looks like a cone or a revolve of a surface shape here. But now I'm going to make a new surface body because we don't have any options for join. It's not like solid modeling where you'll have join. You're always going to make a new body every time you do a new surface. And we're going to see if we can get body 2, and we'll see what it looks like. And here we have body 2 created. So body 1 and body 2. Now notice there's a number in brackets next to that. That number is basically telling us how many segments that body, that surface body, is made out of. In this one, for example, 1, 2, 3, and 3 in the other one as well. 1, 2, 3. Now, because you've made two separate surface bodies, they operate as two separate things. So we cannot see them as one single body. So what happens if I want to take this and make this a solid? Well, I can go to my create panel and say thicken. If I go to my create panel and say thicken, I can select the faces which I want to thicken, and I'll select 1, 2, 3, and I can maybe make it, let's say, 3 mils. You'll see that I have some options to thicken my surface, either on the inside or on the out, or both directions. If I want to make it go the other way, I can say -3, and it goes inside. So that's my front of the surface, and it goes inward. I also have the option to do symmetric, where it stays in the center and goes out 3 mils in both directions. Of course, you can see I'm only able, if I do that, I can select multiple faces from different bodies. However, you'll notice that it will not give me the OK button. And the reason for that is because they're from two different bodies. I can probably try doing this, and I'll say, all right, well, these will go in the same direction. So that didn't work because we were trying to go in different directions and it didn't know what to do. So if I go -3, here we go, -3, and I'm doing all. So when I say OK, it's going to create a new solid body as body 3. So that becomes 1 because they're joined like so. What else do we have? So what I'm going to do is I'm going to create a offset plane from perhaps here. I'm going to say maybe 200. And I'm going to draw something on top there. All right. I'm also going to use an arc. So I will probably use a center point arc. And let's dimension these. 5. Now, I might not be sure what I want to do with this, so perhaps I want to create a loft between these two. Now, notice that because I have a surface body, I can still work with these surfaces and say, all right, let me get rid of this. I want to create a loft between there and there. So I'm going to use my loft tool. And I'll say, I probably want to get some edges on here. But notice how these lofts want to join between them. I want to create a complete closed loop of this to join with a closed loop of that. So in order to do that, I'll probably have to come here and say, listen, this body and this body needs to somehow be joined. And to do that, I'm going to go and use my stitch tool. And I'm going to say the surfaces that must be stitched are that one and that one. And you'll see it'll highlight green where they need to be stitched. And those are the points where it'll be stitched. You'll see my body now becomes one body, body 4. And now let's try and do our loft again. I should select chain selection like so. And then I will select oops. I should probably have done that a lot smarter. So undo chain selection. Let's see if I can do it like so. I'll probably have to go and edit that. Okay, there we go. But obviously this is not right. I'm going to go and edit that little sketch in there just to make it a little better. So that sketch, I'm probably going to need to change this to a construction line. Let's try that one more time. I'm going to use my chain selection. So I'm going to use my Loft tool. I'm going to use my chain selection. I'm going to select another layer here, and we can have that. Notice how it's trying to join as best it can to make this shape. And it will only join on the sides where I need to and not everywhere else. Now, because this is a surface, if I click OK, remember, it's only going to be a new body. And here we have our second body. So of course, the process would be to stitch those two again. So I'm going to say that surface, and it highlights exactly where it needs to be stitched. You can sort of think of it like welding two sheet metal parts together. It will find exactly where things need to be welded. And so we have our unique shape. So what about the other tools and commands we mentioned? Well, let's take, for example, we had ruled surface or patch. Okay, so in order to use patch, let's try and take an example of, I want to make a sort of, I'm going to project some lines here. Okay, and I want to make a sort of curved surface. Right. So I can use my patch tool to say, I want to patch that entire closed loop surface. Remember that they are entire closed loop of one body now, except I want to add in some guide rails. And what you'll see here is that I have a curvy shape around here. It's following the guide rails. And if I do a section analysis, let's say on that bit, you'll see that this is what my shape looks like. I'm going to turn my analysis off now. And so here, we've used just one more tool. Similarly, we can use a ruled offset. And remember how I said that we can have an extrude where you take a line or a sketch and you extrude it in the principal direction that is perpendicular to it. So for example, like so. You can also have a ruled surface where you can take a line and extrude, I say extrude in inverted commas, because you're not actually going perpendicular anymore, but you can go parallel to the plane that the line is drawn on. So if I use a ruled surface, I can say, let's uncheck selection. You can go there, and you can sort of close off maybe half of this. And let's say 150. I'm going to say like so. So you'll find that you have all the tools available to you. And I'm just going to do one more. I'm going to perhaps create a sketch part to do a sweep very quickly. So I'll probably say something like, let's try and project that line or that point. Remember, when working with curve shapes, the fewest lines the better, because control points can really come back to bite you later on. So hopefully this works. Let's try and do a sweep of, if you get a chain selection, and we'll say the path. I don't know. Well, I was supposed to do that particular path there. May have been silly of me not to create this closed loop, but we can change that. We can sort of just project the lines we want. So that line, that line, that line, that line, that line. So let's see if we can do a sweep now. There we go. So that worked. So all this, remember, has 0 thickness. And once we're happy with everything, we can go and make this into one complete body by saying, let's stitch this all together. Saying that, 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 with that. All right. So what are some other features we can do? Well, I did say that we have the option to trim. So if we wanted to make a, I'm going to look at a DZX plane. Let's do that. We wanted to trim perhaps a hole in here. We can say, all right, I'm going to make a slot. Let's say center slot. Perhaps here somewhere. I can use my trim tool to look at that loop and say trim around that loop, and everything inside or outside can be trimmed. So in this case, I want to say those bits need to be trimmed away, and I've made a little cutout for my shape. Of course, I can still use those loops now to extrude out this way, or I can extrude out using the rule surface in a reference direction of my choice. So for example, if I want to extrude out in the direction of, let's see, Y, I can use the rule surface and say, all right, chain select that one, and I'm going to choose a type direction, for example, and I'll choose a reference direction as my Y direction, like so. So I'll say go that way and extrude like so. I'll say 200. Yeah, that looks good. And I'll do the same thing again on the side. Close loop, choose a direction. Direction will be Y, and we'll say 200. Oops, oh, negative 200. And just like that, we've got extra bits there. The extend tool is something similar, but remember, it's just going to extend in the same direction that it was going anyway. So for example, if I had that, or if I have maybe there, just put that particular line, I can, oh, well, that doesn't work, but oh, that's part of a sweep. But any extended surface can be, so any extruded surface can be extended besides your sweep. And of course, we can create what we want from this. So between that one, that one, that one, and that one, I can say stitch all of these together, and it makes them into one body. At which point I can come in here and I can create thicken. Set 3 mils. Now, sometimes you'll get some errors here. So you probably want to select this entire body. Oh, sorry, you probably don't want to select this entire body, but you can come in and thicken just certain faces as you need them. Because remember, when we do a thicken, for example, if we do that, it's going to thicken in a particular direction of that. And if you've got a mix of surfaces, it's probably going to go in the wrong direction each time. One thing you can do is perhaps let's try. Yeah, it's still going to give you an error. So you're going to have to be careful about how you select. So I would just go and select the pieces that I want and say, yep, that's got to be 3 and one side, or maybe just do one at a time. Now notice that it eliminates the body, so you'll have to go back and do the next one. Or it doesn't eliminate it, it just makes it invisible, sorry. And I'm going to go thicken again, 3 mils, and each time it's making a new body of your design. So I've designed something fairly complex without having to do much modeling and cutting out and shaping or what have you. I mean, if you had to think about how this would have been in solid modeling, it would have been quite difficult. Okay. So that's basically how you would use your surface modeling tools. Right. And we will go to the end of the webinar where you can have your Q&A session. So if there's anyone that has questions, you can simply post them in the chat box right now, or you can contact me by my details on the screen right now, and hopefully we'll be able to assist you with your requirements. With that being said, thank you very much for joining this micrographics webinar. I hope you learned something and found something new. Whether you're an experienced CAD modeler or whether you're just a hobbyist learning new things, it's always good to see something different. I'm going to leave my details up on the screen just for you to see. All right. I think my team is attending to the questions and answers. So with that being said, we will end this webinar session. Thank you again and goodbye until next time.